Today we're going to go over an introduction to functions and to identify whether or not certain relations in data sets are functions or not. The first thing that we have to be able to look at, though, to see whether or not certain sets of numbers are functions is a definition. So a function is a relation between a set of inputs. Usually when we do inputs inside of functions, we use an x value. So you're plugging x values into your function or into your equation. And then a set of outputs, usually denoted y, or more often what you will see moving forward is we use function notation, which is f of x. My f is just cursive. You can use a regular f, that's fine. This gives us a little bit more information, so you'll tend to see this used in higher levels of math, where each input, and this is the important part, has exactly one output. So that means that every x value only goes to one y value. The set of inputs for a function, so all your x values, is called the domain of that function, and then the set of outputs is called the range. Okay, so now that we have an idea of what the definition is, we're going to go ahead and talk about how to identify functions versus non-functions. So there are relations that exist that are not functions. These relations have more than one output, so that means that they have more than one y value for any given input. That means one x value would go to two separate y values. To identify non-functions, all you need to find is one example, so that's all you need is just one, where the input has more than one output. So let's talk about these three options first. So a mapping is when you have your set of inputs and your set of outputs. They don't necessarily have to be in order. They happen to here, but they don't have to be. A table, which is a similar mapping situation, except for generally your table is already in order for your x values, and you don't need arrows to identify which x value goes to which y value. And then a list is just listing the pairs of points that are in a table, essentially. So this list, if I wrote it as a table, it'd have -3 and -4 right next to each other, and then 3 and then -4 as well. So let's go ahead and talk about whether or not these are functions or non-functions. So looking at this mapping, you just have to look and make sure that each x value only goes to one y value. So like -3 only goes to 1, so we're good. 0 only goes to -1. 1 goes to 5, 5 goes to -1, and 9 goes to 4. That's fine. So each of these x values only has one arrow coming off of it, and so we would say that this is definitely a function. Another way that I like to present it is to think about your x values being people and y values being birthdays. So like -3 has only one birthday, 0 only has one birthday. And so it helps to make sense of that each x value is only allowed to have one y value. Is it okay that 0 and 5 have the same birthday? Yes, that's fine. But 0 wouldn't be allowed to have like all 4 of these as its birthday. That would just be unfair. The table, you could do the same thing, except for this time you don't have to follow arrows. You just go straight across. So -2 goes to 5, -1 goes to 9, 0 goes to 13, 1 goes to 17, and 2 goes to 21. So we would say, yes, this one's fine as well, because each x value only goes to one y value, excuse me. And then last but not least, you check your list. So -3 goes to -4, 3 goes to -4, 5 goes to 1, and 0 goes to -4. That is perfectly fine. It's okay that -3, 3, and 0 all go to -4. That just means that these numbers all technically have the same birthday, and that's okay. We talked about that people are allowed to have the same birthday. So that is also a function. So now let's go ahead and we'll look at a couple more examples, and we'll do these together. So in this mapping, we can do the same thing. You just kind of follow the arrows. So -2 goes to 0, and then -2 also goes to 1. This is where we run into an issue, because -2, that's one input, has two different outputs. So -2 goes to 0 and 1. That'd be like if -2 had two separate birthdays. That's not allowed. So we would say that this is not a function or a non-function. Okay. Our table, let's check this one. So -4 goes to 1, -2 goes to 0, 0 to 1, 2 to 4, 4 to 9. That is perfectly fine. Each of these x values, especially because none of them are repeated, only go to one y value. So that one is a function. And then the list here, we just got to check and make sure each of our x values only goes to one y value. So 2 goes to -4, 3 goes to -2, -1 goes to 1, 0 to 3, 5 to 7. Then when we run into a bit of an issue here, because we'll notice that 2 here goes to 1, but 2 here also goes to -4. So you have a repeated x value that goes to different y values. So we would say that this one's not a function, it's a non-function, because it seems like your number 2 has 2 separate birthdays. Okay, so that's how you tell from a mapping, a table, or a list. And now what we're going to do is we are going to use a vertical line test to tell on a graph. This is probably actually the easiest way to tell whether something's a function or not, is to use this vertical line test. So to identify non-functions from a graph, we use our VLT, vertical line test. If any vertical line that can be drawn passes through 2 or more points, then the relation is not a function. We say the relation failed the vertical line test. So let's go ahead and look at these examples. If I drew vertical lines through these graphs, this one only hits at 1 point, so that's fine. This one hits only at 1 point, so that's fine. And it has to be any vertical line. It has to be able to go through any part of your graph. And this one only hits at 1 point each time. So we would say that this one is a function. That is good to go. But if we look at example or letter B here, if I draw a line through right here, it hits at 2 separate points. And so all of a sudden that has failed the vertical line test. So we would say that one is not a function. At C, I can draw a line, it hits at 1 point. Another line hits at 1 point. If you draw a line here, that's fine. It doesn't hit at any points, but that's okay. It still technically passes the test because it doesn't pass through 2 or more points. This one hits 0, which is fine. It's less than 2. And then you can do a couple more over here just to make sure. Yep, good to go. That's a function. And then definitely in example D, if I draw a line, it hits at a lot of different points. 1, 2, 3, 4. And so this one obviously hits 2 or more points, so this one would also not be a function. All right, let's go through a couple more of these. So I identify if each relation is a function or not. So I'm going to go ahead and draw my vertical line through 1, 2, 3. Definitely not a function because it hits at 2 or more points. This one, no matter where I draw my vertical line, it's going to hit at only 1 point. So that one's definitely a function. Here, I'm fine. I hit 1 point. Here, I'm fine. I hit 1 point. Here I'm fine, I hit 1 point. And then just real quick, we have to remember, what do open circles on a graph mean? Now, in general, open circles means there's not actually a point here. So even if I drew, to the best of my ability, a vertical line that goes through both your open circles, technically there are no points on that line because open circles mean no points. And so I hit 0 times here. So 1 time is the most and then 0. As long as I don't hit 2 or more times, I'm good. So this one is definitely a function. And if you want to try these on your own before continuing in the video, feel free to do that. I'm just going to go straight through and do it. So pause right now if you want to try them on your own, and then start again and we can see how you did. All right, so if we draw a vertical line through here, whoa, that wasn't exactly vertical. Let's try that one again. Oh, well, it's just going to be that way today. Vertical line through here, 2 or more points, so this one's not a function. And then if I try a couple different vertical lines through here, we're good. Those only ever hit at 1 spot, so those are functions. And then last but not least, through my last graph, all my vertical lines only hit at 1 spot, so again, that's a function. So that is basically how you tell from different data sets. And data sets, remember, could be graphs or they could be tables and mappings like we did up here. Here's mapping, table, list. You can tell from there whether or not those are functions. In summary, if you want to write down some notes here for how to tell whether something's a function or not, from a mapping, you want to look for a non-function would result in 2 arrows from the same x value to different y values. So that would be if you had x values, or like an arrow that went from your x values to two different y values. So one x to two different y's, it'd be like one x value having two separate birthdays. So you got to look out for that. In a table, if you're looking for a non-function, you want to look for repeated x values. So repeated x values to different y values. So if I had the x value of 2 and it went to 5 and 10, then that would be a non-function. In a list, it's going to be the same thing. So actually, I'm just going to draw an arrow right over here. So if you have a repeated x values that go to different y values, that would be a non-function as well. And then lastly, for a graph, you just, to see a non-function and whether it exists or not, you just have to do the vertical line test, abbreviated VLT, and it would fail the vertical line test. So it would pass through 2 or more points. So we started with our definition, we did a bunch of examples, and then we have our summary here. So you can now go ahead and practice identifying whether or not relations are functions or non-functions. Let me know if you have any questions.